And next traffic parameter is nothing but the speed. It is a clear term. Everybody able to understand that the vehicle, what speed it is passing or traveling. In every vehicle, it will be there, right? The 100 km per hour, 120 km per hour. So that speed only we are going to study. What are the different type of the speeds are existing? What is their applications? How to measure the speed? So those things we are going to cover as a small component of your third unit. So speed, basically we can define the speed as a spot speed, average speed, space mean speed, and the time mean speed. Spot speed is nothing but instantaneous speed. Example, this is the corridor. Maybe you just assume the in front of the main gate. Okay, after the bridge it is going on. So one vehicle is passing at this particular point. What is this speed of the vehicle at this particular point? That can be defined as a spot speed. In this spot, what is the speed of the vehicle while passing the line? So that is a spot speed. Average speed, it is a speed of the average. So maybe the 50 vehicle passed for the 15 minutes, what will be the average? So all the speed you are adding and divided by the 50 vehicles, so that will be the average speed of the vehicle. Then there is a two major component, space mean speed and time mean speed. Space is with respect to the how much the with respect to the space. Example, in the same corridor, this is the length you are considering. In this trap length, what will be the speed? That is defined as an as space mean speed. So 1 hour, what will be the number of the vehicle passed in this particular length? From that, what will be the average that can be measured as an as space mean speed? Basically, it is defined with respect to the harmonic mean, and this will be the equation. So space mean speed is equal to total number of the vehicle divided by sum of 1 divided by vehicle speed. So for all the vehicle, I is equal to 1 to n. 50 vehicle is passed, so all the 50 vehicle average we are taking, so that we are defining. So within the trap length, what will be the speed of the vehicle? That is considering as a space mean speed. Time mean speed is nothing but arithmetic mean. The same in the corridor, one spot point you are taking. In that point, within a 1 hour, how many vehicle is passed and what will be the average speed? So that is defined as a time mean speed. So over a period of time, what will be the speed is observed? That is defined as a time mean speed. As an arithmetic mean, it is defined as sum of vehicle speed divided by n. So this is the calculation and this will be the equations. Always the time mean speed is greater than space mean speed, because this is in a defined equations. Vehicles space mean speed sigma squared divided by space mean speed. So how this equation is derived, probably you will be studying in the next semester in the elective subject. But for the understanding, you what the concept is simple: spot speed, average speed. Other than that, space and time mean speeds are there with respect to the harmonic and arithmetic functions, and the time mean speed is always greater than the space mean speed. So this is an understanding you try to learn it from this unit. And one example problem, they have measured the spot speed of the 5 vehicles 50, 80, 60, 58, 78, and they were telling to measure the time mean speed and the space mean speed. Time mean speed is simple, Vt is equal to sum of the speed of all the vehicle. Example 50, 80, 60, 58 plus 75 divided by 5. So this will be the time mean speed. And space mean speed, previously we have seen n divided by sum of 1 divided by vi. So n is nothing but 5 divided by 1 divided by 50 plus 1 divided by 80, 1 divided by 60, 1 divided by 58 plus 1 divided by 75. So what is the value you are getting? That will be the space mean speed. So this is the way we can understand and estimate the speed, how we can measure with respect to the different application. So this is with respect to the one locations with respect to the n number of vehicle we are measuring. Now the question is that one single person or the single vehicle delay, how can we define or measure in the different angle? So that is nothing but the running speed and the journey speed. Your origin is A and your destination is B. Maybe this is your home and this will be the NIT Institute. The running speed is nothing but here you are capturing your flight and you are reaching within 3 hours. So this is defined as a running speed. Journey speed or the travel speed, what it is measuring in the sense, the flight is started to, okay, the flight is started and flight is ending, totally 3 hours plus initially before starting, once you get in, it is going in the runway and it is waiting for the takeoff. It is waiting in the queue. So the queue time or the delay time is included, probably 20 minutes. And sometimes it might be reached the destinations, but it won't get the gate or the runway to land. So that time it is roaming in this particular region for the 30 minutes or the 1 hour. The delay is observed, right? So the delay might be the 1 hour. So overall 4 hours 20 minutes is considered as an journey speed or the travel speed. So this is a way I have explained as an individual person's travel speed, how can be estimated in the term of the running speed and the journey speed. And all the speed we know how we are defining, it might be the kilometer per hour, miles per hours, or the meter per hour or the meter per second, any unit with respect to the space and time, we can define the value for the speed. And the speed is basically it is measuring as a spot speed, previously we have discussed. Then the speed and delay study, which we'll be studying in the next slide. And the speed is mainly used to plan the traffic control rules and regulation, where we can fix the signalized intersection and what kind of the enforcement the law, what will be the what we can say, uh, what will be the speed limit. So all the things we will plan according to the spot speed study, and what kind of redesign or the new designs we can do with respect to the geometric pattern, accident studies, traffic capacity studies, all the practical implemented oriented studies can be clarified and understood with respect to the outcome of the spot speed study. Then the delay studies also can be conducted, where we study about the signalized intersections, how it is performing, how the signal can be optimized, how to reduce the delay, how the operations are happening. So all the things we can study with respect to the delay. So this is the two type of the surveys we can see to improve the traffic efficiency level, movement of the people as well as the vehicle, which ultimately increase the mobility and accommodate the road users for the any country's traffic conditions. The spot speed, basically the spot speed they used to recommend, whenever you want to study the speed, you have to conduct the study during the off peak hour. When it is coming to the peak hour, what happened, the congestions happen, the delay happen, queue happen, we cannot see the maximum speed during that time. When you plan to study about the speed, the study has to be conducted during the off peak hours only. That time only we can able to measure what will be the free flow. But still it is varies with respect to the applications or the objective of your study. And different kind of the methods are there. Manual method, you are going to this field, the two line you are deriving in the corridor, at what time the vehicle is entering, what time it is leaving, the license plate of the vehicle is noted at the both point. According to the time, manually coming to the lab, we are extracting. So this is the way we are doing in the manual way. Other than that, road detector, Doppler principal meters, electronic principal detectors, even the videographic survey also very widely we are using to measure the speed of the vehicle. So all the equipments might be laid on the field. So based on that, it might be extracted. or you capture 1 hour video at this particular corridor, come to the lab and you know what will be the trap length, playbacking the video, you can extract what will be the speed of the exact vehicle. So this is the way. Two methods are there. One is the manual, the second will be the automatic, where we can extract the speed of the vehicle at the given corridor. So that is one example I have explained here using the endoscope or the mirror box, how it is measured in the base length. The last way is that representations. We learn what is the speed, what type of the speeds are there, and why we are conducting the speed, how to measure the speed from the field. We have learned this flow. Now, what way we can represent the speed? The speed usually we used to define as an 15th, 50th, 85th and 98th percentile speed. So this is very important. Probably you might be getting the questions, theoretical questions for your competitive exam. The 15th percentile is defining the minimum speed of the vehicle which can be followed in that particular corridor. Then you know the medians or the average speed. 85th is nothing but the maximum speed we can follow, and 98th percentile speed is the design speed of that particular road. So you want to construct the new road, the design speed might be the 160 kilometer per hour, but the signboard we are giving the maximum kilometer of 100 kilometer per hour. So this 160 is estimated from the 98th percentile speed. The 100 is defined as an 85th percentile speed. So this is an example how we are applying the design speed for the constructions, and the maximum speed we are enforcing. Also the minimum speed has to be followed, probably 30 kilometer per hour. The median speed useful for the analytical purpose, probably the lab work under. So this is the four major representation of the spot speed: 15th, 50th, 85th and 90th percentile, and each speeds are indicating the minimum, median, maximum and the design speed. How we are getting the speed of the 90th percentile? Basically, we are plotting the graph between the frequency of the vehicle, cumulative frequency of the vehicle, and the speed can be taken. So between these two, when we are plotting, so yes, it is given average value of the each speed group of the vehicle in X, and the percentage of the vehicle or the cumulative value of the vehicle is plotted in the Y. And we are connecting all together, you will be getting the bell shape or S type of the curve. From that you will be getting all the percentile speed. So this is the representations of the spot speed, the graph how we are plotting between the speed as well as the frequency. Based on that, the 85th or the 98th, whatever the percentile is required, that can be estimated. So let me explain with one example problem. Okay, this is the problem. It is given the speed range 30 to 40, 40 to 50. So like that, the speed range is given. Maybe 1 hour data is extracted. In that 1 hour, between the 30 and 40, only one vehicle is traveled. Between the 40 to 50, 5 vehicles are traveled. 50 to 60, 28 vehicles are traveled. So likewise, within the speed range, how many vehicles are observed, that can be given in the particular problem. Speed range in kilometer per hour and number of vehicles observed in that particular speed interval. Now they are asking determine the upper and the lower values for that particular given data, also to check the design speed, which means that they were asking 98th percentile design speed, 85th is nothing but the upper speed limit, 15th is nothing but the lower limit. So this is what they were asking. Let me explain how to estimate it. So speed is given 30 to 50. So in this speed range, the mid value we have to take it as an average, so 35. In that value, the frequency is observed as 1. So this is the way we were observed the frequency. Likewise, when it is coming to the 40 to 50, the average is nothing but 45 and number of vehicles observed is 5. So each interval you estimate what will be the average vehicle speed. That average speed is estimated and the frequency is 1, 5, 28 and all. It is given in the problem. So 1, 5, 28, 50 to 37, everything is given in the problem. You try to estimate what will be the total. The n can be estimated. From the n, what will be the percentage for the each one? So that can be estimated. This 0.7 is nothing but 1 divided by n into 100. So that can be estimated as a percentage frequency. So how much percentage it can be estimated. Then the next column will be the cumulative frequency. So here 0.7 will be there. When we are adding 0.7 and 3.3, you will be getting the 4. When you are adding 4 and 18.4, you will be getting 22.4. So 22.4 and 34.2 when adding, you are getting 56.6. So this is the way you can estimate the cumulative frequency. And finally, when you try to plot the graph between the cumulative frequency and the speed in the range will be the x-axis. Speed in the range, this will be the 35, 45, 55, etc. Then the frequency, it is reaching 100, 10, 20 and 100. And you plot between the 35 is nothing but zero point 0.7. So likewise, you can plot and you will get the S curve. From this is 100 and what is a 98? According to that, what will be the speed? 15th, this is 10 and 15th, what will be the according to the speed? 85th, according to that, what will be the speed? So this is the way you plot the graph and you try to identify according to the given percentile speed. It was a very simple mathematical oriented. That is the reasons I'm not giving in the much detail, but it is easy to understand. That is the way I'm just explaining. After the class, whenever you are getting time, you try to work it out to this particular problem using your graph. So this is the way how to estimate the design speed or the minimum or the maximum speed of the given corridor. Basically, they used to give the speed range and the number of the vehicle. From the speed range, you try to estimate the average speed 30 to 40, the middle is 35, 40 to 50, the average is 45. So likewise, else 40, 50 divided by 2, that means 90 divided by 2, 45. So average is calculated. Frequency is given. You know what will be the total number of the frequency. Based on that, you estimate the percentage of frequency. Then you try to estimate the cumulative frequency. Once you know the cumulative frequency, then you plot the graph between the average speed of the vehicle. That means the second column as an x-axis. Fifth column is nothing but the y-axis. Plot the S curve and estimate 15th, 85th and 95th percentile. And what is the point is meeting in the X, that will be the respective speed. So this is the way we can estimate the speed of the vehicle according to that your design problem. Finally, so these are the other method, the field method techniques, we can say floating car method, sitting in the car, how to estimate the delay. With respect to the license plate, we can estimate the delay. Then you can conduct the interview with the driver. Elevated observations, which means that you put a camera, from the camera you capture how the delays can be observed. Then the photographic technique, a little bit the advanced now, the drones also used. So these are the methods we can study about the speed and the delay of the vehicle in the given corridor. So this is an overview about the speed, the much detail it is there. In case if you are getting the much interest in this traffic oriented topic, the best suit is the next semester traffic engineering and the safety, where each method you are going to study with respect to the concept as well as the problems. So yeah, here we can conclude the today's session. The second major component, the speed of the vehicle, we try to understand different type of the speed, like the spot speed, average speed, time mean speed, and the space mean speed. And one simple problem we have seen. Other than that, when it is coming to the individuality, what is the journey speed and the running speed, that we try to learn it. Then what are the applications of all the speed, smart speed or the delay speed, that we given as a point by point. Then the manually to collect the speed using that equipment, how we are collecting. The finally the spot and delay speed with respect to the floating car or interview method. So these are the some of the methods which we used to follow for the research as well as the practical purpose. Once you get a clear picture of the speed and the understanding, what way we can representations. So that typical S curve we have seen, and with respect to the one simple problem, how to estimate the 98th or the 85th or the 15th percentile or the median speed, that we learn it. So for a better or the more understanding, I request everyone to solve that simple problem which we have gone through in the today's session. Solutions I have given. You try to plot the graph. From the graph, you try to estimate the percentile speed of the given problem. So this is the content about the speed. The tomorrow class we will try to study about the parking and the accident. Any doubt from the today's session, student? Okay, if there is a no doubt, we will wind up today's sessions. We'll see you on tomorrow's second level. Thank you, everyone.
Thank you, sir.